So the first one, we're adding 4x and negative 10x. Now since they're different signs, we're going to take a subtraction. Again, 10 minus 4 is 6. So we're going to get 6x. But because the 10 is the biggest number, we're going to get a negative. Now, for the second one, we're going to distribute the negative 7 to the x and to the negative 3. So we're going to get negative 7 times x plus negative 7 times negative 3, which is going to give us negative 7x plus 21. So for number 3, we're going to distribute that 1/3 to both of these, which is going to give us 1/3 times 6x plus 1/3 times 9. Now both of these are going to be, we can put them over 1 to be able to multiply them easier, which is going to give us 6x over 3 plus 9 over 3. And again, this is going to simplify to 2x plus 3. Now for number 4, we're going to distribute this negative. Remember, this negative, you can think of it as a -1 when distributing. So it's going to be 15 minus x, then -1 times -2 is +2. Okay guys, so we're going to combine the 15 and the 2, which is going to give us, right here, -x plus 17. For number 5, we're solving for x. Remember, you want to make sure the x term is alone. So to do that, I'm going to subtract this 2 on both sides, which is going to give us 3x is equal to 8 minus 2 is 6. And again, to get rid of that 3 that's in the x term, we're going to divide it by 3 both sides, which is going to give us x is equal to 2. And lastly, again, we're going to solve for the x, so we're going to add that 1/3 term on both sides. Now in order to add a whole number with a fraction, we have to get a common denominator. Now the common denominator in this case could possibly be 3. So I'm going to multiply both of the terms by 3, which 9 times 3 is 27, and 3 times 1 is 3. So it's going to give us 1/3 x is equal to 27 over 3 plus 1 over 3. It's going to be 28 over 3. Now, since we are multiplying by a fraction, you guys remember we can multiply by its reciprocal. The reciprocal of 1/3 is 3 over 1. So multiply by 3 over 1 in order to cancel out. That is going to give me, in a simplified version, 28. So that's what your x is going to be. So today we're going over solving equations in one variable that contains variable terms on both sides. That could be an example of, let's say, 3x plus 8 equals 2x minus 7. That's an example, because you have a variable on this side and a variable on the other side. Like I said, we're not solving it for right now, so let's move on to the next slide. So, to solve an equation with variables on both sides, we got to use the inverse operations to collect the variable terms on one side to the other. So, for the example that we had before, okay, here's 3x plus 8 equals 2x minus 7. So they're telling us the helpful hint. Let's read it and then we'll solve it. Our equations are often easier to solve when the variable has a positive coefficient. Keep this in mind when deciding on which side to collect the variable from. What they mean by collect, guys, is using the inverse operation to move one term to the other. In this case, I would actually recommend you guys to move the 2x. Because the 3 is bigger, it's going to actually give us a positive x. So 3x minus 2x is just going to be a positive x. Let's say plus 8 is equal to negative 7. Now, to finally finish this, we're going to subtract 8 on both sides, and we're going to get that x is equal to 15. Negative 15, since they are both negative. Alright, so let's solve this one together. Now we have a 7n minus 2 equals 5n plus 6. I'm going to subtract the 5n to try to keep my n positive. Again, if you were to do it the other way, it's okay as well. It's going to subtract it from one side to the other. We're going to get 2n minus 2 is equal to 6. Now I am going to add 2 on both sides to cancel that out. I'm going to get 2n is equal to 8. And finally, since it's 2n being multiplied, I'm going to divide both sides by 2. And I'm going to get n is equal to 4. Now guys, if you rather have moved, I'm going to rewrite it on the side. If you'd rather subtract the 7 first, that's okay too. Is you're just going to have a negative value, which you're going to have to get rid of at the end, as we always want the variable to be positive. But I'll show it to you guys anyway. If I subtract by negative 7, I'm going to get negative 2. It's equal to negative 2 plus 6. Then I'm going to subtract both sides by 6 in order to get rid of the right. And that's going to give me negative 8 is equal to negative 2n. I'm going to divide again by negative 2 since we want the variable to be positive. And we're going to get that negative 8 divided by negative 2 is just 4. And that's going to give us n. So as you guys see, it doesn't matter which one you do first. The key part is for you guys to keep it constant and the signs to match. At the end of the day, it will work out to the same answer. So I will not ask you. Make sure you keep the variable positive. It's more of a whatever you guys feel more comfortable with. I personally like keeping it positive. It makes my life easier. I don't have to worry about that many negatives towards the end. So again, it's up to you. To start this off, you guys can go either way. I'm going to subtract the 4b first, and then I'll show you guys the other way. That cancels that out. And I'm left with 2 equals, again, 4 minus 3 is 1. The 4 is bigger, so it's going to be negative 1b. Now, because that b is negative with that negative 1, I can divide it or multiply it by negative 1 in order to cancel it out. And 2 over negative 1, it's the same thing as saying that negative 2 is equal to b. Now, I want to do it the other way so you guys have it as well, which is subtracting the 3 first. If we do that, it's going to cancel that out. We're going to get, again, 4 minus 3b is 1b, plus 2 is equal to 0. Now, why do we put 0 on that side? Since we moved the 3b to the other side, the equation is still equal to something. So we have to keep the 0 if we don't have anything on the other side. Again, guys, 1b is the same thing as saying b. So I'm going to subtract the 2 on both sides, which is going to give me 0 minus 2. It's just negative 2. So b is equal to negative 2. Again, doesn't matter the way you do it. You still get the same answer. Just please make sure that in this case, the second way we did it, you do equal it to 0 as you get rid of the term that's technically being equal to, but it's still an equation that you can solve. So it still becomes 0, the end. So I'm going to try to keep the variable positive in this one. So I'm going to subtract 0.3y on both sides. So I'm going to get 0.5 is equal to, again, this is a subtraction. So it's going to be 0.4y. It's positive because the 0.7 is bigger, minus 0.3. Now I'm going to add 0.3 on both sides. So I'm going to get 0.8 is equal to 0.4y. Now I'm going to have to divide both of these by 0.4. Now, remember, guys, if you were to do this right now, you can have a number outside with a decimal right here. So we're going to have to move the decimal over on both of these ones. So it's going to end up being 8 divided by 4, which is just 2, because 4 times 2 is 8. So we get that y is equal to 2. So I'm going to do it the other way as well. So I'm going to erase everything right here. So the first time around, we kept the y positive. Now let's make it negative. Subtract by 0.7y. So we're going to get 0.5 minus 0.4y is equal to negative 0.3. Again, it's still a subtraction, 0.7 minus 0.3. In this case, that 0.7 is bigger, so we keep the negative 0.4. I'm going to subtract by 0.5 on both sides, which is going to give me negative 0.4y is equal to negative 0.8. Since these two are the same sign, we add them together. They just become a bigger negative. Now I'm going to divide by 0.4 on both sides. And again, I get y is equal to, again, 0.8 divided by 0.4. It's the same thing we did before. Since we can't have that decimal outside, we're going to move it once. We're going to move it once. It's going to be 8 over 4. Still 2. Now, the reason it's positive is because we have a negative up in the top and a negative up in the bottom. So the numerator and the denominator of that fraction. And a negative divided by a negative is a positive. Again, to solve more complicated equations, you may need to first simplify by using the distributive property or a combination of like terms. An example could be something like this. So this is what you would consider a more complicated equation because you have to distribute this 6 to both of these. 6 times 3 is 18, 18x. 6 times 2 is 12. And then we will have to combine this 3 and this negative 2 to get a positive 1 plus 7x. Then you would solve it the same way we've been doing. Subtract in both cases by 7x. So that's going to give me 11x plus 12 is equal to 1. I'm going to rewrite it up here. 11x plus 12 is equal to 1. I'm going to subtract by 12 on both sides, and I'm going to get 11x is equal to negative 11, which when I simplify, dividing by 11, I get x is equal to negative 1. So that would be considered technically a more complicated equation because you have to distribute and you have to combine like terms. So to solve for this one, I would start by combining like terms. So we have this 6a, this 4a on the left side. So let's start with the left side first. We're going to get 4 minus 2a is equal to negative 1 minus 5 times 7 minus 2a. Now, since I can't do anything left on the left side, I'm going to actually go to the right side and distribute this negative 5 to both of these terms. Just write down how that would look. 4 minus 2a is equal to negative 1. It's going to be negative 5 times 7 plus negative 5 times negative 2a. And when I simplify the left side, it's just written the same way. I'm going to simplify the right side. So 1 is negative, so negative 1. Negative 5 times negative 7 is negative 35. Plus negative 5 times negative 2a is positive 10a. Now that I simplify that, I can actually go ahead and combine these two terms. And I'm going to get 4 minus 2a is equal to negative 36 plus 10a. Now here I'm going to keep the a positive by adding 2a on both sides, which is going to give me 4 is equal to negative 36 plus 12a. Afterwards, I'm going to rewrite it up here, guys, so we can keep going. I'm going to add the 36 on both sides, and I'm going to get that 40 is equal to 12a. I'm going to simplify by dividing by 12 on both sides, and I get that a is equal to 40 over 12. Now, I do expect you guys to try and simplify, so we're going to simplify by 2. Divide by 2 on both sides. I'm going to get that a is equal to 20 over 6. And I can still simplify this one more time by 2, which is going to give me a is equal to 10 over 3. I would also accept this as a mixed fraction, which is 3 1/3. Now I am going to erase the work from here down to show you guys the other way. I am going to leave the final answer up there to show you that it's the same thing. Now I'm still going to combine like terms like I did. So up to here, I would say just keep it the same way. Sorry, it's not 36, it's not 26. It's negative 36. Now, we're going to do it with the variable being negative this time. So I'm going to subtract the 10a from both sides, which is going to give me 4 minus 12a is equal to negative 36. Afterwards, I'm going to subtract the 4 on both sides, and I'm going to get, again, I'm going to write up here, negative 12a is equal to negative 40. Now remember, you want to make sure the variable is positive, so the letter. So I'm going to divide by negative 12 on both sides, which is going to give me 40 over 12, because the negative 40 over the negative 12 is going to simplify to a positive 40 over 12. Now, again, I would simplify and divide both by 2, the same way we did before. We're going to get that a is 20 over 6. I'm going to do it one more time. I'm going to get that a is equal to 10 over 3, which is, again, the original answer that we had. So it doesn't matter which way you do it, as long as you follow the rules of PEMDAS backwards in order to solve for the variable. Not to simplify. If you're simplifying, which is what we did at the beginning, like distributing and combining like terms, you do follow PEMDAS for that. If you follow all the rules and you make sure the variable, in this case the letter A, is positive, then you will get the same answer. Doesn't matter which way you do it. So for this one, we're going to distribute this 1/2 to both of them. Again, please don't be afraid of fractions. They are your friends, and I promise you they work out. So it's going to be 1/2 times b, so 1/2 b, plus 1/2 times 6 equals 3 over 2b minus 1. Now this 6 right here, I'm going to make it an over 1, so it's easier to multiply with that fraction. So you're going to have 1/2 b plus 6 over 2 equals 3 over 2b minus 1. Now, this is where you would be able to go one or three ways. The first way, which is one I would recommend you all the time, is to make sure if you can simplify anything else, and you actually can. This fraction right here simplifies. So we get 1/2 b plus 3 equals 3 over 2. b minus 1. Now, this is where you can go one or two ways. You can either make the variable positive or make it a negative. Let's do the positive way first. I'm going to subtract 1/2 b on both sides. So it's going to be 3 is equal to 3 over 2b minus 1 over 2b minus 1. The reason I rewrote it is because seeing fractions written like that makes it a lot easier to do. Now, because their denominators are the same, I'm able to just subtract it easier. So I'm going to keep writing up here. So it's 3 equals 3 over 2b minus 1/2 b is just 2 over 2b minus 1. Now the next step I will do is add this 1 to both sides, which is going to give me 4 is equal to 2 over 2b. If you guys notice, this 2 over 2 simplifies to 1. So I'm just going to go ahead and write 4 is equal to 1b. And because it's a 1 in front of the variable, you can just write 4 is equal to b. And that would be your answer. So I'm going to go ahead and erase the work up to right here. I'm going to leave the final answer up there so you're able to realize that we get the same thing. So I'm going to write in blue. 1/2 b plus 3 equals 3 over 2b minus 1. Now in this case, I'm going to make the variable negative. So I'm going to subtract 3 over 2b. And I'm going to get 1/2 b minus 3 over 2b plus 3 is equal to negative 1. Now again, I wrote it that way to make it easier to see, so I'm going to keep writing up here. 1/2 b minus 3 over 2b is negative 2 over 2b. Plus 3 is equal to negative 1. So now I'm going to subtract this 3 on both sides, and I'm going to get negative 2 over 2b is equal to negative 4. Again, this 2 over 2 simplifies to negative 1b is equal to negative 4. I can rewrite it as negative b equals negative 4. Now, we're almost there. Remember, the variable, in this case the letter b, always wants to be a positive. So I'm going to multiply the whole thing times negative 1. When I do that, I get that b is equal to positive 4. And we have the same answer. The first step I will do is realize that there's two sides of the equation, right? I'm going to start with the first side. So I'm going to start with this one. Just because I'm going left to right, there's really no reason to it. The first thing I can do is look if I can do anything. I can combine like terms. So I'm going to get the 3x plus 6 is equal to 2 times x plus 2. Afterwards, now since there's nothing else I can do on the left side, I'm going to go ahead and work on the right. I can distribute to be able to simplify. So I'm going to get 3x plus 6 is equal to 2 times x is 2x. 2 times 2 is 4. So 2x plus 4. Afterward, this is where you can go one or two ways. The first, I'm going to keep the variable positive, so I'm going to subtract 2x from both sides. And I'm going to get x plus 6 is equal to 4. Afterward, I subtract by 6 on both sides, and x is equal to negative 2. Now, I'm going to go ahead and work and rewrite it on the right here. And show you guys the other way. I can subtract the 3x and get a negative x. So 6 equals negative x plus 4, which in turn I'm going to subtract the 4 on both sides, and I'm going to get that 2 is equal to negative x. Now, since x needs to be positive, the actual variable, I can multiply or divide this by negative 1. I'm just going to do multiply, and I'm going to get that negative 2 is equal to x. Again, these two numbers matched. So it doesn't matter the order that you do it in, as long as you make sure you follow the rules. So an identity is an equation that is true for all values of the variable. An equation that is an identity has an infinitely many solutions, and some equations are always false. These equations have no solution. So for example, this would be an equation, the one that it's all has infinitely many solutions. So this one would be something that would equal at the end, let's say. So here that would be infinitely many solutions because 2 is always equal to 2. For example, in the other one that it says that is always false, we would have something, let's say 0 is equal to 4. Now since 0 is never equal to 4, it's a no solution. We will go over it in the next couple of examples. This is just an overview so you guys understand how the answers may or may not look. So, identities and false equations. So identity in words is when solving an equation. If you get an equation that is always true, the original equation is an identity and has an infinitely many solutions. So for example, we have this thing that says 2 plus 1 equals 2 plus 1. So 3 is equal to 3. That is correct. If I were to actually, let's say, add 5 on both sides, it will make this equation 8 is equal to 8, which is still a true equation. So as long as it's the same on both sides, you will be fine. As you guys see here, we have 2 plus x and 2 plus x. They're the same. They just subtracted the x to cancel it out here, and they got a 2 is equal to 2. Okay, now for this one, these are the false equations. So in words, a false equation is when solving an equation, if you get a false equation, the original equation has no solution. So if you guys see here in numbers, we have 1 is equal to 1 plus 2. So since 1 is never equal to 3, because 1 plus 2 is 3, we can say that it's a no solution. The same thing applies to algebra. We have x is equal to x plus 3. They subtracted the 3 to move to the other side. It canceled out. So now we were left with 0 is equal to 3. Again, that is not true, so it's a no solution. Guys, there's the ways I would write no solution in your answer would be NS. You can write it out, no solution. Or you can do this circle with a line and it would still be acceptable. So please keep that in mind. Any of those three are okay for no solution answers. Let's work on this one together. I'm gonna, again, just work on each separate side as its own entity until I'm unable to do anything else. So for the red side, we have 10 minus 5x plus 1. The only thing I can do this there is combine the 10 and the 1. So I'm going to get an 11 minus 5x is equal. And then that's it. That's all I can do on the left side. So I'm going to go ahead and do the blue. I can combine the 7x and the 12x. So I'm going to get a negative 5 plus 11. There's absolutely nothing else that I could do there. So I'm going to go ahead and add that 5x to both sides. And it happens to cancel out in both sides. In doing that, I get that 11 is equal to 11. So this is on all real numbers. You guys will see me write this down in like this, all real numbers. All real numbers. Or this weird shape. Those are the ways I write all real numbers. Please attain or do use the one that you prefer. I want you guys also to realize that 11 minus x and minus 5x equals negative 5x plus 11. It's the same thing, it's just flipped. So if you notice that they're the same already in that step, you can stop and just say all real numbers. If you don't and you feel better subtracting or adding the variables, in this case we added the 5x, then go ahead and do so and you will get an answer at the end of the day. In this case it's 11 equals to 11, which is all real numbers. So again, I'm going to circle or square the left side and square the right. This is just so I take it one step at a time while I'm explaining. You guys don't have to do it if you don't feel like you need to. I'm going to combine the x's on the left. So I'm going to get 13x minus 3 equals. There's nothing else I can do to the red, so I'm going to go ahead and move on to the right side. 5x and 8x. We're going to get 13x minus 4. Afterwards, I am going to subtract the 13x from both sides. And they cancel out. So I am left with negative 3 is equal to negative 4. Now, since negative 3 is never equal to negative 4, this is a no solution answer. So for this one, again, just going to separate the two sides. I'm going to do the red side first. I can combine the y's together. So 4y minus y is 3y plus 7. That's going to equal 10 plus 3y. Now, I haven't done anything to that side. I also cannot do anything to the blue side. Since I can't do anything to the blue side, I just went ahead and wrote it down. Now, I am going to subtract the 3y on both sides. And they happen to cancel it again. And we get 7 is equal to 10. Again, since 7 is never equal to 10, we can say that this is a no solution. And that will be your answer. Again, I'm going to go and separate them. I'm going to notice that I can do the c's on the right side. So it's going to be 3c plus 7. It's going to be equal to... Now let's do the blue side. We're going to see we can combine the negative 14 and the 21st. So it's going to be c plus 7. Now I'm going to go ahead and subtract 3c from both sides. and I'm going to get that 7 is equal to 7. Now, this is always a true statement, so it is all real numbers. Now, your homework is on Canvas. You do have homework tonight. Now, please, if there's any questions, let's ask.